Assalamu alaikum, my dear students. How are you? I think you are all well with the grace of Almighty Allah. Welcome to NIEVS Home School. I am Yamin Apu, an assistant teacher of mathematics, National Ideal English Version School, morning shift. Today I am going to take a higher mathematics class for the student of class 9. Okay, today's lecture number is 3. Okay, we have no homework today or for the half yearly examination. Okay, and our topic is chapter 1 part 3 basic discussion. Chapter 1 part 3 basic discussion. In the previous classes, Imdad sir have discussed already part 1 and part 2. We will discuss today part 3. Okay, in part 3 our discussion topic is Venn diagram, Cartesian product and 1-1 correspondence. Okay, I repeat, it's Venn diagram, Cartesian product and 1-1 correspondence. Dear students, Venn diagram, first of all, read this one. Okay, Venn diagram is expressing set related information in diagrams is quite convenient. These diagrams are named Venn diagram after the name of John Venn. That means John Venn is the name who created this diagram. Okay, and we can express any set or any kind of set with the help of the diagram easily. Okay, suppose there is a set. Suppose, dear students, there is set A is equals to 1, 2 and 3. Okay, U is a whole set, that means union set is 1, 2, 3, 4 and 5. Then we can express A prime set or a set A with the help of the Venn diagram. Very easily. How? Look, suppose there is a rectangle here. Okay, we can assume this rectangle as the set U. We can express this rectangle as the set U. That means this rectangle has all the values 1, 2, 3, 4, 5. That means 1, 2, 3, 4, 5. All the elements of U has in this rectangle. Now we can express this in this diagram also the set A. How? Look, in the set A we have 1, 2 and 3. Then if we draw a figure like this, then this indicates that this circle indicates that this is A. This circle is the set A. Okay, and we can identify also another set which is A prime. Okay, A prime is what? A prime is, we know in the previous class, A prime is equal to U minus A, right? Or you can express this as U minus A. Okay, this is our same. So we can express this set also in the prime set, A prime set. How? Look, U, the value of U is 1, 2, 3, 4, 5. And minus, we have to subtract it from A, 1, 2, 3. We have to subtract from A. We have to subtract A from 1, 2, 3, 4, 5. Okay. So subtracted, it will be how much? 1 should be subtracted, 2 should be subtracted, and 3 should be omitted. We will get only 4 and 5 as the prime set of A. Okay. So this is our A prime set. That means we can indicate this outer part of a set A. This outer part you can indicate as A prime. Okay, I think dear students you have understood. That means this Venn diagram can be written down as like this one. Okay, for the set, for the two sets, these are the two sets U and A. We can express this is the set U. Okay, this is the set A and this is called A prime. This is the set A and this is called A prime. In the set A, this element is 1, 2 and 3, and the A prime's set has the element 4 and 5. I think this you have understood. We can express another Venn diagram. Suppose there is another set B. Okay, B is equal to 6. Distance B equal to 6. So we can express it by union. So U set has also the set of B because U is the whole set. Then we can construct U is this rectangle angle, that means this Venn diagram. In this Venn diagram, U, this rectangle is totally 1, 2, 3, 4, 5 and 6. All the elements have in this U. Okay, and this set is A, we can indicate this is A set A, okay, and this is the set B, and these two sets are disjoint. These two sets are disjoint. Like this one, we can express any set by the help of Venn diagram very easily. Okay. Now, dear students, our second topic is we have to discuss the Cartesian product. Okay. The Cartesian product, I have write down there what is Cartesian product, and I give also the example here. Okay. It's so easy. Look, the Cartesian product is what? The Cartesian product set of two sets A and B is A cross B is equal to X and Y, the set pair of set of X and Y, where such that X is belong to A and Y is belong to B. It says that A cross B is the set of all pair of X and Y such that X belong to A and Y belong to B. Okay, here is an example I have given. A set A is A, B, C of elements, okay, and B is the set of element of 5 and 6. Then when we do the cross product of A and B, it will be A cross B equal to A5. I am writing this one again, okay. A is the set of A, B and C. The students, B is another set of, here is 5, 6. So our cross product A cross B will be how much? A cross B will be all the set pair of A, B, C and 5, 6. That means all the set product of X, Y, which therefore there is this X belong to A and Y belong to B. So our sets will be how much? Look, X will be first, Y will be second. This will be our pair, and X must be in the A and Y must be in the set B, right? So X means the element of A, B and C of elements A. Okay, so here will be first element will be X, that means A, and the second element will be Y, that means 5. This is a pair, okay, and like this all the pair we have to write down. First number, the first element will be A again, and the second element will be Y, that means 6. So A is done. Then we have B, the element B, and we have 5 again. Then we have B and 6, okay, B with 6. So other pairs is C pair, okay, C5 and C6. It will be C5 and C6. This is, now we have write down all the set pair here, okay, of the set A and B. A has the 3 element, A, B and C. B has the element of 5 and 6. So we will get how many products? We will get the set pair of 6, because A has 3 element, B has 2 element, right? So when we do the Cartesian product, we will get how many pairs? We will get 6 pairs, because 3 multiplied 2 is equal to how much? 3 multiplied 2 equal to 6. So we will get 6 pairs, and 6 pairs are this pair, okay. And in the pairs, the element of X, that means the A's pair will become first, and the sets B's pair will become second. I think you have understood it, students. Now, the last topic of today is it's one-on correspondence. One-on correspondence is very easy. It's an operation. One-on correspondence is an operation. Look, the definition is if the matching of an element of B with every element of A and an element of A with every element of B are established, such matching is called an one-one correspondence. Between two set A and B, one-one correspondence can be expressed as this one, can be expressed as A correspondence B, okay. We call it A is one-one correspondence to B, okay. We call it A is one-on correspondence to B, and there will be, suppose there will be an element, there is an element X belong to A, and there is another element Y belong to B. If we say that X and Y is correspondence, one-on correspondence, then we write X is one-on correspondence to Y, okay. That means A and B, two sets are one-one correspondence. The students, this is a operation, or we can say that, and another example, I can write another example, 1 two elements, okay, which belongs to the set A. And suppose there is A and B, two elements belong to B. If we write down A is 1 correspondence to B, then it must be 1 is correspondence with any of the element. That means suppose A, okay, 1 is correspondence to A, and it must be also 2 need to 1 correspondence with B. Then we can call that A is 1 correspondence to B, okay, and we call it A is 1 correspondence to B. Dear students, I think you have understood. It was so easy topic today, and you have no homework. Dear students, keep practicing more and more at home about your parents, and stay home, stay safe. See you again, inshallah. Allah Hafiz.